Welcome to Lesson 5.5. This is the last lesson that we will do in Unit 5, and we're going to focus on multiple angles today. This deals with two particular types of identities that we're going to focus on, and there are more listed in your text in this unit, but we are only going to deal with double angle identities and half angle identities. And these do need to be memorized, and you'll notice these are the double angle. They've got sine of 2 theta, cosine 2 theta, tangent of 2 theta. These are the half angles. They're all theta divided by 2. I'm going to scoot it up a little bit so you can see another tangent. And when you're doing these, keep in mind that there are different identities and equalities that you could use. Tangent has 3 of the half angle, and cosine of 2 theta has 3 as well. So maybe put them on flashcards, index cards. Somehow learn to memorize these, and the more familiar you are with them, the easier they will become. I also want to show you that they can adapt to the multiple angles. For example, if we look at the sine of 4 beta, well, right up here, and I know I keep shifting it, I'm sorry, this says the sine of 2 theta. I want 4 beta. Well, if I expand that to be the sine of 2 times 2 beta, then I can use this identity because it's expanded such that it's 2 times whatever that theta is, and that becomes the sine theta and cosine theta. Well, right there, instead of just theta, I have 2 beta. So when I expand this, I have 2 times sine of 2 beta and cosine of 2 beta. That gives me an equality for sine of 4 beta. That's how you can apply this to the multiple angle. Here for cosine, when I do the cosine, I'm going to scoot it up a little bit, of 6, that one can be expanded, cosine of 2 times 3u, and then whatever's there, remember you have an identity for cosine of 2 theta, so I'm just going to take whatever this theta value is, and it's the cosine squared of that value, which is 3u minus sine squared of 3u. So you can adapt these, and as I said, the more you use them, the more familiar they will be. The first example I would like to talk about is if you were given a triangle and you're given 2 sides of the triangle, the sides 1 and 4, you don't know the hypotenuse, and I would like you to find cosine of 2 theta. Well, you need to, first you can pick any of the equations that you want. If I'm going to say cosine of 2 theta, I'm just going to pick the first one, cosine squared minus sine squared. And I can get cosine from my triangle, but it would be, here we're going to make that theta, it would be the adjacent over the hypotenuse, but I need my hypotenuse, right? So that would be 4 squared plus 1 squared, so this is in the square root of 17. So my cosine value is going to be 4 over the square root of 17 squared minus the sine value would be 1 over the square root of 17 squared. It's very nice because you're squaring these square roots and everything will disappear. Right? So here you have 16 seventeenths minus 1 17th, answer 15 seventeenths is the value for cosine of 2 theta given those values on that triangle. Let's do another example. Example 2 says solve the following equation, cosine of 2 alpha plus sine squared of alpha equals 0, and we'd like this to be on the interval from 0 to 2 pi. All right, when you're evaluating this, you've got a cosine of a double angle plus sine squared. Well, remember you had 3 identities for cosine of 2 alpha, but I have a sine squared in my equation. So when I decide which one of these I'm going to use, that's got cosine sine, only cosine squared, only sine squared. So I'm going to use this last identity right here. and I'm going to say that the cosine of 2 alpha is equal to 1 minus 2 sine squared of alpha. And let me see, and I'm going to then add the sine squared that I already have. Negative 2 of them plus 1, I'm going to have 1 minus sine squared. I'm going to move the sine squared to the other side, so I have 1 equals sine squared. Take the square root of both sides. I then get plus or minus 1 equals sine of alpha. Well, where is sine positive and negative 1? At pi over 2, and negative 1 at 3 pi over 2. Those are my two values on that interval. Okay, let's try another example. Example 3 says if sine of beta equals negative 4/5 on the interval from pi to 3 pi over 2, find the sine of 2 beta. We're finding another double angle, and this interval right here puts me in quadrant 3. So let's go ahead and play with that while we're thinking about it. And we know that we're going to need to play in that quadrant here. So I'm down in quadrant 3, and there's beta. I know that sine is negative 4/5. So that makes this negative 4 opposite over hypotenuse. I don't know my adjacent side, but you do. This is 25, right? Square root of 25 minus 16. So this is not 3. But what kind of 3? It is a negative 3 because I am in quadrant 3. Right? The x is negative as well as the y, sine, cosine, and sine. So now we can go back and find this value. You have one equality. So we're dealing with the sine of 2 beta. Our identity is 2 sine beta cosine beta. We'll go to your triangle. That's going to be 2 times the sine we already know is negative 4/5. That was given. But the cosine now, because you have your triangle, the cosine is negative 3/5. Well, that's positive 12 times 2 is 24 25ths. That is your value. Let's try another example. Example 4 says to find the cosine and tangent of 75 degrees. Well, it's a little odd because 75 degrees is not something you can just go to on the unit circle. So we have to figure out a way to make it something that we can go to on the unit circle. And it's similar to what we did in 5-4, but when we did sums and differences, you can go that route. You can also use the half angle identities. And if we need to remember that we're playing with 75 degrees, and we need to remember that that's in quadrant 1. So we'll go back to that, and we need to remember that we are in quadrant 1 where cosine and sine are both positive. But if we want to let's let theta over 2 be the 75 degrees. If we do that, then theta is what? Double that, which would be 150. I know the values at 150 on my circle. So if I want to, and he wants me to do cosine and tangent, if I find the cosine value at 75 degrees, I'm going to use my half angle formula for cosine, and that would be plus or minus the square root of 1 plus cosine of theta. Well, we already said that that theta is 150 over 2. Well, I know what the cosine value at 150 is. So Here I can do the square root of 1 plus, at 150, think about that on your circle. You're right here. What's the cosine value? And that is negative square root of 3 over 2 over 2. Now it's just algebra. Now it's simplifying this. Let's get a common denominator here in the numerator. This would need to be 2 over 2, so I would have 2 minus the square root of 3 over 2, and that's alone in the numerator. So I have all what's under the radical here. I have 2 minus the square root of 3 over 2, and if I'm dividing by 2, that's the same thing as multiplying by a half. So that gives me the square root of 2 minus the square root of 3, and I know that I've got a square root and a square root. That bothers some of you, but it's okay. Over 4, and you can split that up, right? Take the square root of the numerator divided by the square root of the denominator, which you know. Square root of 4 is obviously 2. So then I have the positive and negative square root of 2 minus the square root of 3 over 2. Now I can't stop there. That's not my answer. We have to determine, is it positive or is it negative? All right, and since cosine is positive in quadrant 1, the solution is positive as well. So our positive answer is 2 on the minus, get that in there, minus the square root of 3. I messed that up. Square root of 2 minus the square root of 3, all over 2. And sometimes you'll see it this way, just 1/2 on the square root of 2 minus the square root of 3. I think I like that one better. So we'll leave the answer like that. Okay, now I asked you to find cosine and tangent. So let's go ahead now and use the half angle formula for the tangent. This one says the tangent of 75 degrees, and we're going to use our formula. And again, there are 3 of them. So you can pick, really. There's not, in this particular case, a right or a wrong way. I'm going to say 1 minus cosine of the 150, right, of the theta, divided by the sine of 150. And I'm going to work that one out. So that gives me 1 minus, remember 150, we just did this, is over here. So the cosine at 150 is still negative square root of 3 over 2. And the sine at 150 is a positive 1/2. Okay, clean that up. We know that that common denominator is 2, but now it's plus the square root of 3 over 2. And when you divide by 1/2, the same thing as multiplying by 2 over 1. My 2's cancel, and the product is 2 plus the square root of 3 as my final answer. We've got one more example. And I think what I'll do, since I'm about at 14 minutes, I'm going to go ahead and prepare that one for part 2. It won't be very long. And so this will be the end of part 1. I will see you again in part 2.